Friends, today we are going to discuss about the module 2 that is based on that is fin chapter. So a problem is like this: the one end of the long rod is 35 mm in diameter, is inserted into a furnace with the other end projecting in the outside air. After the steady state is reached, the temperature of the rod is measured at 2 points 180 mm apart and found to be 180 degrees centigrade and 145 degrees centigrade. The atmospheric air temperature is 25 degrees centigrade if the heat transfer coefficient is 65 watt per meter square degrees centigrade. Calculate the thermal conductivity of the rod. Okay, this problem is related to the circular fin because the diameter of the fin is given, so we assume it is a circular fin. Okay, circular fin. So diameter is given. Okay, diameter is given 0.035 meter. So we will write given data. So first, diameter of the dia of the rod. The rod you consider here as fin. D is equals to external surface, it is so 35 mm, 0.035 meter. And the atmospheric temperature, air atmospheric temperature, there is T is equal to 25 degrees centigrade, and the heat transfer coefficient, H is equal to 65 watt per meter square degree centigrade. First, what we have to do, the starting point x, the value at this point, consider that x is equal to 0, at x is equal to L if you consider. At starting point at x is equal to 0 is considered that at the first point where the temperature is measured, and at x is equal to L is considered at the outer point. Assume the thing is what it is. We have to assume the end of the rod fin is insulated. Very important assumption is assume the end of the rod is insulated. It is very, very important. If you assume it is like this, you should write according to that equation. For insulated, we have equation. For insulated and we have equation that is theta by theta naught is equal to T minus TA divided by T naught minus TA is equal to cos hyperbolic ML minus X divided by cos hyperbolic ML. Okay, now at x is equal to L, okay, at x is equal to L, what happened? This equation reduced to above equation becomes so if you substitute as L minus L 0 into anything is again 0, cos hyperbolic 0 is 1 divided by cos hyperbolic ML. So here what happened? theta L is 145 minus 25, which was 125 degrees centigrade. Okay, and theta naught is equal to theta naught minus theta A, theta 180 minus 25 is equal to 155 degree centigrade. So we can write 120 divided by 155, 1 divided by cos hyperbolic ml. Okay. Or we can write cos hyperbolic ml 155 divided by 120, 1.29. Here ml is equal to 0.747. Therefore m is equal to 0.747 divided by L. Also we can write m is equal to HP by KA. We know that equation. Okay. So HP by KA also is equivalent to 0.7471 L. We can equate it, right? So here HP by KA is equal to 0.741